Hi, I'm Mario Graf, and today I'm going to talk about collocations using Wald test. The approach that I'm going to follow is to go through some code in order to explain some of the behavior of this test on the finding of collocations. What we have seen is that we can use the Wald test to find if a particular bigram doesn't follow a independence assumption. So we can use that if we have a set of tokens, words, and then we have a set of bigrams, then we can iterate for all the bigrams and compute the Wald statistic. In fact, we are not computing in this algorithm the exact Wald statistic, because the exact one will involve an absolute value, and we are not using the absolute value, but we are going to analyze what happened. Okay, I'm going to go to VS Code. What we are going to use is this library that can be found in GitHub on the Ingotech GitHub. It's the library text models, and there you can find the class that we are going to use. So if I execute this part, okay, I'm going to execute it, and then okay, this part is we are going to create a tokenizer. The tokens that we are interested in are the bigrams -2 and -1, which means the words. And just as an example, is good afternoon. We will make some nice word clouds, and we can see here that it's the word good and afternoon, and this is the bigram. This is a bigram, and the two words are concatenated with this symbol. Now, I just downloaded a few books from the Gutenberg project. In fact, I downloaded 25 most downloaded books in English, and then we can iterate for all these books, and then read them and use this instance of the token count class to process the information, to process each of the books that we are going to. What we are doing is just counting the number of words and bigrams that appear in all these books. I'm going to do that and show you in this variable in token counter. What we are having is a counter instance that contains bigrams, words, and the number of times they appear. Just in a few minutes we are going to see. And so I told you, this counter contains the words and bigrams. So at this point we are interested only of the bigrams. So if we go through the key and found the symbol, it means that it is a bigram. So we can do that, and just to have an idea which of the bigrams are the most frequent. These are the 5 most frequent bigrams. With this information, we can create a word cloud. We are using this library to create the word cloud. Well, it's quite easy just to create it. I'm going to tell this terminal that I wanted the picture inside it, and we can see the word cloud. And it is not very informative because it contains only the most frequent bigrams. We are seeing the most frequent with bigrams. But what we can do now is to compute the Wald test. The Wald test involves, in order to create the Wald test, we need to count the number of bigrams that we have seen in the corpus. This can be computed just by iterating for all the values and sum all the values. The values means the number of times each particular bigram appears. So if we sum everything, then we obtain the total number of bigrams that we have seen. With that value, with n, it is almost 3 million. With that value, we can compute the probability of seeing a particular bigram, and we are going to see the bigram in there. And with that information, and Also with the words. Let me retrieve the words. A word is a key in the dictionary that doesn't contain this symbol. This symbol is reserved to indicate that it's a token. And now we can obtain the words. Just have a look at the words, and the Wald statistic we are going to store the Wald statistic in this dictionary. So we iterate for all the particular bigrams. We iterate for all the bigrams, which are going to be in W is the bigram, and B is the number of times that bigram appears. We iterate for all of these, and we compute the Wald statistic. Well, not exactly the Wald statistic. We remove the absolute value. Let me execute this. I don't know if it's going to be fast or not. And in order to view, we are going to see this. We are going to create a word cloud. Create the word cloud, and what we are seeing is something that we didn't expect, which is also something very, very similar to the frequency. Let me try to explain why we obtain this result. This result is obtained just going through, for example, the most frequent bigrams and showing the Wald test. I'm going to try to show you that even though that we are seeing the same thing here, like a frequency, this is not the frequency, and the bigrams and the frequency and the Wald test are two separate numbers. As we can see here, well, the frequency is getting lower, but on the other hand, the Wald statistic is, okay, this is lower, but this is higher. So we can see that they are not computing the same thing, but still we don't have information to know why we are seeing the same thing. In order to try to explain that, what we are going to do is to create a box plot, to create a scatter plot of the frequency, which is going to be this one. This list is computing the frequency and versus the Wald statistic. We do this, and what we can see is that, of course, they are not computing the same thing. They are computing something different, but this is not too informative. Let me try to do a little bit more, or to explore a little bit more. To do that, what I need to tell you is that in this line, what we are seeing is we are only focusing on the positive numbers of the Wald statistic. So let me try to create this. I mean, we didn't filter the negatives one, but the word cloud is focusing only on the positive. I mean, the negatives are just very, very low numbers. That is what is happening. So they are internally, this library is normalizing everything from 1 to 0. So a negative number is very, very close to 0. So it is almost irrelevant, and a positive number are the relevance one. In order, having said that, what we can see to visualize what I just told you is changing, just focusing on the Wald statistic that is positive in this scatter plot, and we can do that. I think I have it here. Yes, I have it here. What we can do that is just to look for all the, okay, we are iterating for all the values that are in this dictionary, that are the Wald statistic for all the bigrams, and we are seeing if the Wald statistic is greater than 0, then we are keeping the keyword, and we iterate for all the keywords and do again the scatter plot. And what we can see on the scatter plot is that the frequency increases, the Wald statistic also increases, as you can see here. It is not perfect. There are some examples that doesn't happen that, for example, in this one or in this one, but generally what we are seeing is that if we increase the frequency, then we are increasing the Wald statistic. and, and the consequence of this is that the output is going to be very similar because we are somehow looking at the frequency, not at the Wald. Well, we are looking at the Wald statistic, but the Wald statistic is behaving like the frequency. Can we, let me go here. Can we fix that? Well, yes, we can fix that somehow if we look only at some point, at some particular frequency. So instead of doing the word cloud for all the frequencies, just look at one of those frequencies. Let me try to focus only on one of the frequency. Let us focus on the 15, just the number 15, and see how the word cloud looks like. Okay, the word cloud of that frequency, that particular frequency, looks like this one. And as you can see, it's more informative. You can see names here. I'm sure there is another name around there. Well, I cannot see that, but you can see some words that are not stop words. You can see this expression that it's weird, this one that it's weird. So let me try to show you what is happening there. I just have been I have this file that is one of the books, and you can see here this line. You can see this kind of pattern name, and then 0txt or 0zip and asterisk. So what we can see, what we can do to see the pattern is we are going, let me tokenize this expression, this sentence, and see what happened. And if we tokenize it, what we can see here is this pattern that we are seeing here in this word cloud. And it is good to find that our algorithm is able to find that pattern, because this bigram is really weird, and it is not an independent. So it is not independent. That it's good. It is occurring because the independence the independence condition is not met. Okay, and I already told you that there are 25 books, so 15 is a good number. Maybe there are other patterns that are not. Maybe other names doesn't. Other books doesn't have this pattern. But let me continue with this. We have seen that if we change the frequency, if we focus only on a particular frequency, then we are going to see something interesting. But we haven't talked too much about what happens if we use, for example, this one, if we use the absolute values. Let's try to do that. What we are going to see if we change that, I'm sure I have something in here that can help me do that. Yes, I have some code here that can help me. If you remember in the Wald, the dictionary that contains the Wald, I didn't use the absolute value, so I can use it here. I can just put it here, the absolute value, and then see the word cloud. And what we are seeing is, okay, we are seeing something really weird, which is this one and this one. But what we are seeing this is that, well, these two words, then and and, they form a bigram, and they kind of never what we are seeing here is, okay, to show you what we are seeing here, what I need to do is to make a little bit of change. Is instead of doing the absolute value, what I'm going to do is change the sign of the value, so in order that the positive numbers that we saw in the first kind of word cloud, instead of seeing those positive bigrams, just like that have a positive wall value, we're going to see the bigrams that contains negative values, and very negative values in fact. And if we plot this, what we can see is that these two word clouds are similar. So if we use the absolute value, when the absolute value is used, what is happening is that we are focusing only on the negative ones, and those tokens are the ones that have the higher magnitude in the Wald test. They might be, some of them, informative. And let me try to go into the math. What we are doing is that this is the probability of the tokens being independent. That is the product of the probability of word 1 product multiplied by the probability of the word 2. This is what is computing this part, and this is the probability estimated from the two words together. So what is happening here is that this value is a lot higher than this one. It's more probable if we look at the words individually, then by chance they are going to appear more frequently than if we look at the corpus. So, what this is telling us is that they are not independent, they are dependent, but if we saw one of those words, the most likely behavior is that we are not going to see the other word. This somehow is modeling some characteristic of the language. Perhaps it is not useful to find collocations, but it is useful for something. At least we know that if we found these two words, this is kind of uncommon expressions. Let me continue with this description of, we have just seen the bigrams of frequency 15, and I told you that there were 25 books. So let us look at what happened when we look at 25 books. If we look and see what happened when we look at 25 books, well, we can also to find something that it is in all the books. If I go to this book and then go up, what we are going to see is kind of a header, and that header is, I can look for it, but we are going to find this string in all the books because it is okay. I'm making a mistake here. Well, if okay, can I just can look for goals and see? Okay, we can see that. Yes, this part. Okay, we are, the tokenizer is consuming this bit, and we can see here that this part, this sentence, is found in all the books. That is why if we say, okay, I want to see the frequency 25, what we are going to see is the header of all the files, because that is shared for, and it is good that we are finding something that it is not independent, but it is artificially not independent. The point is that the algorithm that we are using is finding something, but the data that we use, it is artificially created, and the algorithm is highlighting something that it is not useful. Now, we can continue with that, and well, what we can do now is try to, for example, try to understand what is happening. We can, let me try to go to, let me put another time this one. Okay, that one doesn't help. What about if instead of looking at the positive voltage and the positive numbers, we look at the negative ones, which are the ones that are not kind of doesn't follow. And for example, we can look in the data in the books, we can look for some of these patterns, I of, or I don't know. Let me try to look up for that pattern. I'm going to switch to the terminal. Okay, I'm going to close this. Sorry. And I'm going to switch to the terminal, and I already kind of write down that part. And okay, this is the expression that I of, and you can see here where this expression it is found. As we have seen, sometimes the tokenizer is consuming some characters, so we are not going to find all the tokens that we are not going to find exactly what the tokenizer is doing because it is transforming the input, but we can have kind of an idea of what is happening. So this pattern is very uncommon, and these are the sentences that, or at least the lines that contain that pattern. So if you can see, well, at least there are, I don't know, okay, this is just one book, and well, all of others are different books. Let me go, and I think I have this one. Let me go to this last word cloud that has been computed already. What I did to compute this word cloud, I removed the header of all the files, and I think I only removed the headers of the files, and we can see some interesting. Well, we can see some patterns that these are persons. This is another person's. This is another person. These are names of the books. So, and somehow this, by looking only at some particular frequency, we are generating word clouds that are informative, and we can look at some of these patterns. I have one of these. As I already told you, the tokenizer removes some characters, so I kind of tried to figure out which pattern was this, because there is an isn't there that it is removed by the tokenizer. But if we look at this, then we can see where this pattern is found in the book, and we can see that it's this particular book. So Vescova, Countess Vescova, is only in one book, which is kind of obvious because it is a book, because not that it's a uncommon name, that it's not going to be in all the 25 most frequent books. But that gives you an idea how to start debugging the algorithm about how to start debugging this algorithm about collocations and the use of Wald test. And as you can see, it's not directly that you are going to use it and then you are going to find a nice result. For me, that is all. And well, if you have any question, just send me an email.